Sai Ram. Dear learners, welcome to Shri Sathya Sai Lok Seva Gurukulam online classes. We are doing Mathematics Class 8th Chapter Playing with Numbers Part 3. In the last part, we had seen certain tricks with two-digit numbers and their explanation. In today's session, we will be looking at three-digit numbers. So the topic, Oscar and Steve are two friends who decided to play an indoor game. Steve asked a set of questions and Oscar agreed to do whatever Steve says. Steve said, choose a three-digit number and don't tell me what is it. Oscar said, all right. She chose a number and the number that she has chosen was 135. Now make the number by reversing the digits. This was the instruction given by Steve. Oscar said, all right. She had chosen the number 135. So the reverse number becomes 531. Then Steve said, subtract the smaller number from the larger one. So 531 minus 135. And let me tell you, learners, Oscar was doing all the calculation mentally. So she subtracted 135 from 531 and got 396. Now divide the answer by 99. This is what Steve said. And he said that I'm sure that there will be no remainder. So Oscar had to take pen and paper to do this. 396, and she was asked to divide it by 99. And when she was doing it, she tried 99 multiplied by 2, 99 multiplied by 3, 99 multiplied by 4. When she multiplied it by 4, she got 396. So the remainder is 0. Oscar said, yes, you are right. There is indeed no remainder. But this time, I think I know how you are so sure of this. Because Oscar had seen through Steve's tricks when two-digit numbers were involved. What had happened? Suppose Oscar had thought of number 927. On reversing the digits, the number becomes 729. Subtracting the 2, she got 927 minus 729 equal to 198. She divided 198 by 99 and got 2 as the quotient with no remainder. And this is just what Steve had predicted. Let us try the same with numbers 471 and 103. So number is 471. On reversing the number, reversing the digits in the number, we get 174. Subtract the smaller from the bigger one. 11 minus 4 is 7. 16 minus 7 is 9. 3 minus 1 is 2. So 297. And now we have to see whether 297 is completely divisible by 99 or not. Let's do it by 3. 3 nines are 27. 2 carry. 3 nines are 27 plus 2 is 29. So remainder is 0. So the same trick is true for number 471. Let's see what happens if the 3-digit number is 103. On reversing the number, it becomes, on reversing the digits, the number becomes 301. We have to subtract smaller one from the bigger one. So 301 minus 103. So 11 minus 3 is 8. 9 minus 0 is 9. 2 minus 1 is 1. So we get 198. Let us divide 198 by 99. It goes by 2. 2 nines are 18. 1 carry. 2 nines are 18 and 1. 198. So remainder is 0. So what had happened? Let's generalize it. Let the 3-digit number chosen by Oscar is ABC. And we have already done in part 1, the first session of this chapter, how to write a 3-digit number in expanded form. So ABC will be written as 100A plus 10B plus C, because C is at the units place, B is at the tens place, and A is at the hundreds place here. On reversing, what will we get? On reversing, the number will become CBA. So that means C is at the hundreds place, so 100C is written here, plus B is at the tens place, so 10B will be written here, and A is at the units place, so plus A. Now, whether we assume that A is greater than C or C is greater than A, in both the cases, answer will come the same, only the sign would change. So ABC minus CBA, let us put the values, and when we open the bracket, you see 10B gets cancelled. 100A minus A is 99A, and C minus 100C is minus 99C. 99 comes outside the bracket, that means 99 is taken as common, and in the bracket we get A minus C. Had CBA been greater than ABC? This could also be the option that A is less than C. In that case, we would have done CBA minus ABC. In that case, we would have got 99C minus A. In both the cases, 99 is coming. Now see, if 99 is coming outside the bracket, that means the resulting number is divisible by 99. So the remainder is 0. I hope it is clear to you how it has been done. And please try the same trick with numbers 937, 201 and 489. Let's move ahead. Gaming with 3-digit numbers continues. Again the same friends, Steve and Oscar. Steve asked Oscar to think of a 3-digit number and not to share the number with him. So he says, now use this number to form 2 more 3-digit numbers. Oscar thought of a number. Say Oscar thought number 123. She was further asked to make 2 other numbers using the same digits. Original number was 123. This was the original number. The next number she thought of was 312. In fact, she changed the places to get the number 312 and the other number 231. 123 was the original number. The digits were shuffled to get 2 more 3-digit numbers using the same digits. The other numbers were 312 and 231. Then Steve said, add them up. Now let's see. 123, 312, 231. Add them up. 666. So after adding, Oscar said, what next? Now divide the resulting number by 37 and I claim that there will be no remainder. So 666, this is what Oscar had got, the sum of the 3 numbers. Let's divide it by 37 to see what comes. 37 ones are 37. You can multiply in the rough and see whether 296 gets completely divisible by 37 or not. Let's try with 8. 8 sevens are 56. 5 carry. 8 threes are 24. 24 plus 5 is 29. So what is the remainder? Remainder is 0. And this is exactly what Steve had predicted. Oscar said, yes, you are right. By now, Oscar had the impression that Steve is a very, very intelligent person. So what had happened? Suppose Oscar had thought the number 837. The 2 other numbers that were formed using the same digits are 783 and 378. Dear learners, please be very careful how it has to be done. First number chosen is 837. When we have to form the other 2 numbers, take the last one, that is 7 has to come here and 8 and 3 will be written as it is. Then 3 will come in front and 7 and 8 will be written as it is. So in each row, we have got 3 digits, 8, 3 and 7. In each column also, if you see, each of these digits should come once. Here you see 8, 7, 3. 3, 8, 7. 7, 3, 8. So we have to be careful. What are the other numbers been formed using the same digits? Now here 7 plus 3 is 10. 10 plus 8 is 18. Then here also 18. 18 plus 1 is 19. Carry 1. Again this sum is 18. 18 plus 1 is 19. So 1998 is the sum. And she divided it by 37. When 1998 is divided by 37, 5 sevens are 35, 3 carry, 5 threes are 15, 15 plus 3 is 18. 9 minus 5 is 4, 9 minus 8 is 1, 8 comes down. Let's try with 4. 4 sevens are 28, 2 carry, 4 threes are 12, plus 2 is 14. So we get the remainder 0, and this is just what Steve had predicted. So will this trick work always? By now you would be sure, yes, all of Steve's tricks, they work always. Let's take the general form A, B and C, which is a short form of the digit. Well, we are writing it in expanded form, 100A plus 10B plus C, because C is at the units place, B is at the tens place and A is at the hundreds place. So we have to shuffle the digits. As I said, original was A, B, C. Now bring C ahead in the beginning. So it becomes CAB. Now after getting CAB, just bring B towards the left hand side. So it will become BCA. You can check in each column and in each row whether A, B and C are coming once or not. If we see in this column, it is ACB, second BAC and third one CBA. Write each of these numbers ABC, CAB and BCA in expanded form. So CAB will be written as 100C plus 10A plus B. BCA will be written as 100B plus 10C plus A. Add these three. After adding these three, we can open up the bracket here. It will be 100A plus 100C plus 100B plus 10B plus 10A plus 10C plus C plus B plus A. Now put all the A's together. 100A plus 10A plus A. So these three will give us 111A. We will get 111A. Then let us look at 100C, 10C and 1C. So this is also 111C. Now what about B? 100B plus 10B plus B. So this will be 111B. We take 111 common and in the bracket we are left with A plus B plus C. 111 can be written as 37 into 3. And the next bracket would be A plus B plus C. So we see that in each case the resulting number is divisible by 37. So the remainder is 0. I hope the explanation of this trick is clear to everyone. Let's try the same with numbers 237 and 117. So our original number is 237. We have to form two more numbers using the same digits. Last one is 7. I'll put 7 here. 2 and 3 will be copied in the same sequence. Now, for the third number, 3 we will take from here and 7 and 2 will be copied in the same sequence. Now, you can check each row and column whether we have 3 different digits there or not. Here we have 2, 7 and 3. Here we have 3, 2 and 7, and in the last column we have 7, 3 and 2. After this we add. 7 plus 3 is 10, 10 plus 2 is 12. This is also 3 plus 2, 5, 5 plus 7, 12, 12 and 1 carry 13. Again 1 carry, 7 plus 2, 9, 7 plus 2 is 9, 9 plus 3 is 12 and 1 carry, so it becomes 13. So our number is 1332, 1332. Now divide 1332 by 37. Just see what remainder are we going to get. Let's do it with 3. 3 sevens are 21. 2 carry. 3 threes are 9. 9 plus 2 is 11. Subtract them and 2 comes down here. Let's see by which number will it go. Let's try with 6. 6 sevens are 42. 4 carry. 6 threes are 18. 18 plus 4 is 22. So our remainder is 0. So this trick is again validated. Now let's see for number 117. As I said, take the last digit. Last digit is 7. Other two will be copied as it is. Again, take the last digit, which is 1, and 7 and 1 will be copied as it is. You can check in each row and column, are we having 2 1s and 1 7? Yes, we are having that. Add them up. This will be 9, 9 and 9. So if we have 999 and we divide by 37, what do we get? Let's do it by 2. 2 sevens are 14. 1 carry. 2 threes are 6 plus 1 is 7. Subtract. Let's do it by 7. 7 sevens are 49. 4 carry. 7 threes are 21. 21 plus 4 is 25. So our remainder is 0. You'll try the same with numbers 317, 263 and 885. Gaming with letters and digits. Let us look at some puzzles in which letters take the place of digits. 2 rules that we follow in doing these puzzles. Each letter in the puzzle must stand for just 1 digit. Each digit must be represented by just 1 letter. And the first digit of a number cannot be 0. That is quite clear, because if it is a 2-digit number, so 2-digit number cannot start with 0, because if it starts with 0, a 2-digit number will become a one-digit number. So, first digit of a number cannot be 0, whether we are talking of 2-digit numbers or 3-digit numbers. So, that is one thing we'll have to take care of. And second is, each letter in the puzzle must stand for just one digit. Let's do some questions. Find A and B in the addition of A plus A plus A gives you BA. This is already written. Now we have to see what do A and B stand for. A will have just one digit. For example, if say A is 0. So 0 plus 0 plus 0, we get 0. Answer is only single digit. So this is not permissible here in this particular question. The addition of 3 digits should give us a 2-digit number in such a way that the units place in the answer has the same digit. Now, try it. If we take 1, 1 plus 1 plus 1 is 3. Again, is not possible. What about 2 plus 2 plus 2? Gives us 6. Again, not possible. 3 plus 3 plus 3 gives us 9. Again, the answer is a single digit number. And moreover, the digit in the units place is not same. What about 5 plus 5 plus 5? What do you get? We get 15. Can you correlate this with a given question? Do you think A plus A plus A gives BA and 5 plus 5 plus 5 gives 15? Are the digits satisfying the given condition? If you see here, 5 can be written in place of A. So 5 plus 5 plus 5, and answer is BA. So A is 5 and B is 1. You'll have to practice questions to do these kind of problems. There is no formula to solve them. You can try with each of the digits from 0 to 9 and see that it gets satisfied with number 5. Let's take some more questions on similar lines. For example, we are given 3A and 25 is added to it and we get B2. We have to identify what are the digits that should come in place of A and B. Now here you see what should you add to 5 so that you get something that ends with 2. If you put 0 in place of A, it will be 5 plus 0 is 5. We don't get 2 here. What about 1? If you add 5 plus 1 is 6. We do not get 2. What about 5 plus 3? 8. Again, we are not getting 2 at the units place. Then what about 5 plus 5? 10. 0 comes here. No, we want 2 at the units place. What about 7 plus 5? 7 plus 5 is 12. 1 carry. So what will come here? 3 plus 2 is 5. 5 plus 1 is 6. So from here you can see that A corresponds to digit 7 and B corresponds to 6. Or we can say A is equal to 7 and B is equal to 6. Another one, 4A plus 98 gives us C, B and 3. First thing that you will see is A and 8. What should you add to 8 so that you get something that ends with 3? This is quite easy. What should you add to 8 so that you get a number which ends with 3? So what would that number be? If we add 5 to 8, we get 13, 1 carry, and 4 and 9 is already given out here. So what will it be? 14. So from here tell me what is the value of A? A is 5. What is the value of B? Compare. B is equal to 4. And what does C equate to? C is equal to 1. Let us take a problem on multiplication. 1A multiplied by A gives 9A. First of all, just see here, A multiplied by A gives a number which ends with A. If we see 1 multiplied by 1 gives 1. But can we have 1? Put it here. 11 into 1, it will come 11. We are not getting 9 out here. So 1 is not possible. If you put 2 here, 2 2s are 4. Here only we are not getting the same digit. We have to get the same digit here. So how will we get the same digit? You can check with each of the digits from 0 to 9 and see what are we going to get here. Yes, try it. Let me try it with 5. If I take 5 here, what will come? 5 5s are 25, 2 carry, 5 1s are 5 and 2 is 7. But we are supposed to get 9 here. So 5 is also not possible. We rule it out. What about 6? 6 6 are 36, 3 carry, 6 1s are 6 plus 3 is 9. So we get 9 here in the tens place. So what does A here represent? Which digit does A represent? A represents 6. We'll do questions of similar types in the next class. That is all for today. Thank you so much. Om Shri Sai Ram.